This is a Miss Albans physics video that covers how to represent motion with position versus time, velocity versus time, and acceleration versus time graphs. So we have the following situation. You stand still for 3 seconds and then walk with a velocity of 1 meter per second for 2 seconds. And we want to graphically represent this motion with the following graphs. So if we're standing still for 3 seconds, the graph that may seem the easiest to fill out is the velocity graph. So if we aren't moving for 3 seconds, we know that the velocity for the first 3 seconds will simply just be 0. So this is what the velocity versus time graph for the first interval will look like. If we know that there's no change in velocity, then there definitely isn't going to be any acceleration. So we know that the acceleration will also be 0 for the first 3 seconds. And lastly, if we are not moving for the first 3 seconds, we know that our position will never change for this time interval. So we can say that our position is also 0, which means we assume that we start at the position 0, which is okay. Now let's discuss what happens when we walk with a velocity of 1 meter per second for 2 seconds. Since we have a new velocity, we can pencil this into our velocity versus time graph. Now we know that from 3 to 5 seconds we will be traveling at a velocity of 1 meter per second. And if we are traveling at this velocity of 1 meter per second, we know that after half a second we will have traveled half a meter. After 1 second we will have traveled 1 meter. And after 2 seconds we would have traveled 2 meters. So our position versus time graph will look like this. And lastly, we know that to jump from 0 meters per second to 1 meter per second, we have to have an acceleration. But this acceleration was very brief because from just a little after 3 seconds, we continued at the same velocity. So our acceleration versus time graph will have this temporary spike in it. It is also important to include important instances in our graphs. This way we know what caused the sudden movements in our graphs. Let's do another slightly more complex example. Someone walks at positive 1 meter per second for 2 seconds, then stops for 2 seconds, and then walks in the negative direction with a speed of 1 meter per second for 1 second. Now at the beginning, we know that we are traveling at a positive 1 meter per second for 2 seconds. So our velocity versus time graph will reflect this. We also know that if we are traveling at a constant velocity, that our acceleration is going to be 0. And if our velocity is constant and positive, we are constantly increasing our position coordinates. So the position versus time graph will look like this. So these graphs are very similar to the graphs on the previous slide. Now let's talk about what happens when the person stops. We know that the velocity will return to 0 for 2 seconds because the person is stopped and not moving. Since we had a positive velocity and our velocity decreased to 0, we will briefly have a negative acceleration. This acceleration is negative since our final velocity was 0 and we subtracted our original velocity of 1. So our change in velocity, or delta V, is equal to 0 minus 1, which is negative 1. So here we have a brief decrease of acceleration to negative 1. We also know that if we stop walking, our position won't change. So our position versus time graph will be at a constant 2 meters for 2 seconds. Now let's address the final movement, which is walking in the negative direction with a speed of 1 meter per second for 1 second. Hopefully you thought to yourself, this would mean that we would have a negative velocity. So we know that from our time from 4 to 5 seconds, we have a negative velocity a velocity of negative 1 meter per second. And to go from rest to a velocity of negative 1 meter per second in 1 second, we would have an acceleration equation of negative 1 minus 0 divided by 1. So we know that our acceleration is going to spike down to negative 1 meter per second squared just momentarily once again. And over the 1 second, we would walk 1 meter in the negative direction. So our position versus time graph will look like this. And once again, it's important that we label all important events also within the graphs.